Okay, today we're learning about linear inequalities and how to graph them on a graph. So we know that linear inequalities have an inequality symbol instead of an actual equal sign. We also know that y equals mx plus b is set up like this. They create lines. And ax plus by equals c is set up like this, and it creates a line also. This is called slope-intercept form. This is called standard form. The only difference is we don't have an equal sign anymore. We have an inequality symbol, which means that our line is not going to be the only answer. We're going to have a shaded region, which is going to be the actual answer. Okay, so let's go start graphing this line on the graph. Since it is y equals mx plus b, do you know, guys, which one that I start with? The m or the b?
The b.
The b. The b is the y-intercept. And can you, Derek, point to -4 on the y-intercept for me? Yes. That is the -4 as a y-intercept, so I can put a dot. And then I use my slope to graph. Technically, this is a whole number, so I can say 2 over 1 to make it rise over run. Up 2 over 1, up 2 over 1, up 2 over 1. All right, there's something really important about linear inequalities that we have to know. If we have symbols that look like this, we create a line that is solid, just like normal. If we have a symbol, a linear inequality symbol that looks like this, we create dashed lines because technically it doesn't actually equal that. It is it is only greater than or only less than. So over here I have a solid line going through my dots. Am I done? Did I answer? Am I done?
No, you have to shade.
I'm not done. I have to shade. Shading is part of the answer for linear inequalities. So I have to figure out where my answer is. Guys, do you remember how we test to figure out where the shading goes?
The origin.
The origin. The origin is the easiest point on the whole graph. It's 0, 0. If I test that within my original equation, I can figure out if it works so I can shade or not. So I'm going to put a 0 in for y and a 0 in for x. 2 times 0?
0.
0 minus 4.
-4.
-4. So I have 0. 0 is less than -4. Is that true? No, 0 is not less than negative. True, that is not right, which means that the origin does not fall in my answer set, which means that my answer set, my solution set, is this side of the graph. And that is my answer. All right, let's move on to the next one. It is in standard form, ax plus by equals c. And I have to find my x-intercept, my y-intercept, and my slope. Guys, tell me how to find the x-intercept.
C over
C
A.
over A.
C over A. Y-intercept?
C over
C over
B.
B.
C over B. And then slope.
Negative A over B.
Good job. All right, so since we're taking C over A, I take -3 over, and what number is right there, even though we don't see it?
1.
A 1. A 1 is right here and right here. So I take -3 over 1, which is -3 for my x-intercept, which goes on the x-axis at -3. My y-intercept, -3 over -1, creates a +3. Good job. Goes right here. And then I technically don't need my slope, even though my slope is -1 over -1, which is just 1. Which means that I would have gone up 1 over 1, put a dot, up 1 over 1, put a dot, up 1 over 1, put a dot, which is what we already know. All right, how do I draw my line, guys? Solid or dashed?
Dashed.
Dashed, because there is no or equal to symbol on the inequality. This is a dashed line. And am I done with the answer?
No.
No, I have to shade. And how do I shade?
The origin.
Test the origin.
Test the origin. So I'm going to use some space, I guess, down here. I'm going to plug in a 0 for the x, plug in a 0 for the y in my original equation. 0 minus 0?
0.
0. So this says 0 is greater than -3. Is that true?
Yes.
It is true, which means that the origin is part of my solution set. It is part of my answer. So all of this down here is shaded. Okay.